The sun emits the light with various wavelengths. When you know the wavelengths of light, you can calculate the frequency of the light using the formulas C equal F lambda. C is the speed of light. F is frequency. Lambda is the wavelength of light. The light with a high frequency has short wavelengths. So if F is high F, correspond to the short wavelengths, lambdas, or low frequency correspond to the long wavelengths, long lambdas. The energy flow from unit areas of a star is calculated by summing up all the light with different wavelengths. So from the we consider the unit areas of a stars. So many type of the light is emitted from the surface. Sometimes high frequency or low frequency. Energy flow from the unit area of a star is calculated by summing up all the light with different frequencies. Energy flux is proportional to the force power of the surface temperatures. So energy flux F flux is proportional to the force power of the surface temperature. Force power of the surface temperature. And then proportional constant we call it sigma. We call that this sigma is a Stefan Boltzmann constant. This is called the Stefan Boltzmann Law, and this is Stefan Boltzmann Law. And one of the most useful law in astronomy. The luminosity is obtained by multiplying the energy flux with the surface area of an object. So if we consider the total surface of the stars, the radius of the stars is a capital R. This is a star. Stars. And then from the unit areas, energy flow from the unit area is F. So total amount of areas from all the stars is given by luminosities. So luminosity L can be obtained with a 4 pi R squares. This is surface area of a star times flux. So luminosity can be calculated, surface area of a star times flux. So this means L equal 4 pi R square times sigma T to the fourth. And T is surface temperatures. Of stars. So from these equations, you can calculate the T. T equal L over 4 pi R square sigma. And the power is 1 over 4. And then you can substitute luminosity of the suns and the radius of the suns and the sigma. Sigma is a constant. Sigma is given by equal 5.67 times 10 to minus 8 watt per square meter Kelvin to the fourth. If you substitute all the numbers of the radius of the suns and the luminosity of the suns, you can calculate the temperature of the suns, 5,760 kelvins. So this is a device to measure the temperatures of the object without touching the object. So this is very useful formulas to estimate the surface temperature of the suns. So this is answer to this practice.